Okay, factorizing. Can everyone please mute the mics until they have a question for us? The first thing we do is we can't do anything with the surds. We're gonna change the surds into exponents. Who is this? Making noise. Master Glenn, can you please mute your mic, sir? Ah, this is B 1/2 plus 3B equals 2. This is a very it's a very not nice question. How do we deal with this? Does anyone have any ideas how we deal with this? Can anyone suggest anything? I know that I need to multiply my exponents, so I'm gonna have a 2a definitely. When I multiply exponents, I can add the exponents, so I know I'm gonna have this 2a to the power 1 over 5 multiplied with a 1 over 5 will give me a to the power 2 over 5 because you add the exponents, you multiply with the same base. That's laws of exponents, right? For this last part, I need to get a positive 3b. So when I add my exponents, when I multiply exponents with the same base, I can add the exponents. So the only way I'm going to get anything is if I have a 3b and a half and a b and a half. B and a half multiplied with b and a half will give me a b. I will send maybe extra questions on how to factorize with this. I think I do have in my YouTube there is a video on factorizing. It is there. So to get this positive, I can do negative like this because there's also a negative here. So I can't have two positives. Yeah, I know this doesn't make sense. Even in the memo, there's just two steps. But I will send more questions on this one specifically. But I don't want to waste time on this because it's just a mess with the exponents. Um, I'll make sure we don't get a question like this in our test two because I'm setting your paper up.
Thank you, sir.
Yeah, we don't want to work like with numbers like that. 8x. Who can, okay. For me, this question, it should be, it should have been, yeah. For many people, it was nice, but the only issue was the manipulations. So, what's the first step we do? We say, this is normally our factor. Someone is wanting to join. So what we're going to do is we're going to say 4x minus 1 equal to 0. Take that 1 over. We have 4x, x equals to 1 over 4. The next step, substitute in. So we're going to have 8, 1 over 4, cube plus 4, 1 over 4 squared plus a, 1 over 4 plus 3 equals to, with a remainder of 1 over 4. So I don't want to use my brain too much. So what I'm going to do is I'm going to say 8 times 1 over 4 cubed gives me 1 over 8. Then 4 times 1 over 4 squared leaves me what? 1 over 4 plus a over 4 plus 3 equals to 1 over 4. So what I'm going to do is I'm going to take everything to the other side and then leave my a one side, minus 1 over 4 minus 1 over 8. And I'm left with a over 4 over there. So 1 over 4 minus 3 minus 1 over 4 minus 1 over 8 equals to negative 25 over 8, and is a over 4. Then to get rid of this 4, I multiply with 4. So this multiplied with 4 will give me negative 25 over 2. And that's my a value. So simple it is, yes. But for some reason, I don't understand, but many people, they get lost like between those three steps here. Like I don't know, it is the manipulation or the simplifying, but many people they didn't get this 25 over 2. I think only maybe 3 or 4 people out of the I think the 20 scripts that I marked, they got this 25 over 2. The steps they got the steps, yes. They got this one. They put it in. That's a mark there. There's a mark there and there's a mark there. I think I gave a mark for this step also. But for some reason from here, they just didn't get the negative 25 over 2, which was crazy to me because for me, even if I can calculate this with my hands or in my head, I'll put in a calculator that thing, make sure it's gonna get the number that I want to get. Even if you're very clever and you must put 1 plus 1, you put your 1 plus 1 in the calculator. The calculator will think for you. You can skip a sign, skip a number, but the calculator, you can just check if you have all your numbers in. As long as you get 25 over 2, then you are right, man. Then to check your answer, you can substitute your negative 25 over 2 here, and you must get your 1 over 4 there. Let's also check your answer. But anyways, it was very confusing that the people didn't get that one. 1.3 was completing the square. Yeah, will I have it? Yes, I do have the memo with me, yes. Yeah. So what they were doing is they were combining all those fractions together. You understand what I mean? They were combining all those fractions. See, they had 1 over 8, they had a 1 over 8, they had a 1 over 4, and 3 over 4, and 3. They just combined those fractions into one big fraction. What unnecessary? Yes, 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 And we're doing that. And we are doing that, yes. As you can see, we get our 25 over 2. So what you, yeah. Are you saying it must multiply with the 25? We did multiply both sides. That's why my A is alone there, and why my 25 over 8 became 25 over 2. Okay. No, okay, no problem. Okay, the next one. I don't think I'll have space. Yeah, I don't want to mess everything in here. But okay, let's see how much we can fit in here. So the first step, someone please tell me the first step. What is the first step here? Someone, anyone. The 5 east, the 5 to the left. So take the 5 here. Then it's minus 5. Let's just complete in the square here. Yes, there's two first steps. Either you get the constant to the other side, or you get your x squared alone first. It depends how your question is given. The first step here is to get your x squared alone. But if this constant was this side, your first step would be take out that side. I mean, you can divide with 2 first, you can. It's up to you entirely. But you must just know that you get x squared alone and you get a constant to the other side. That's your goal. Okay. So what do we do now? Divide with the 2. So we left with x squared minus 3 over 2x equals to 5 over 2. Then my next step is to take my x squared minus 3 over 2x. So can we all agree? Can we all agree that this is my b value? That's my b value, right? So I must add in brackets my b value multiplied a half in brackets squared in both sides. So I must do this in both sides. So what you do now is you do a little bit of, you multiply this half in. That's the only thing you do actually. So you're gonna have this. You're gonna have x squared minus 3 over 2x uh, minus 3 over 4 squared. I actually want to keep it like this. Uh, then this side is calculator work. You never want to think or anything, and then you're gonna get 49 over 16. Yeah, never break your brain if it's numbers. If it's numbers, calculator immediately. So what do I do now? My next step would be is to write this x and this number in the same bracket. So it's going to be x, then okay, 3 over 4. Just the number. Take it 1 squared. Now, what I said in the previous class we had, that whatever this sign is here, this sign must come in the middle here. And that sign is a negative. And there's my 49 over 16. So we know by now that we want to get our x alone from here. And to get my x alone, I must square root both sides. So it will become 3 over 4 like that. And then 49 over 16 like that. A very important thing to note. Yes. Square root. When you square root like this, always plus and minus. Plus and minus tells me I'm going to have two sets of answers. I can simplify this one more time. It's going to be plus minus 7 over 4. X minus 3 over 4. And then I'm going to have two values, right? So x1 is equal to positive 7 over 4 plus 3 over 4. I get my answer. X2 equals to a negative 7 over 4 plus my 3 over 4. Now remember, I took my negative 3 over 4, I took it to the side. Twice actually, but yeah, it's just the front sign that's going to be changing. So because I have a positive and a negative 7 over 4, I have two answers. There's my one, there's my second one. You must always do that. Then you put in the calculator. I don't know which one now. Let's do it. So 7 over 4 plus 3 over 4 gives me 5 over 2. And then a negative 7 over 4 plus 3 over 4 over 4 negative 5 over 2. Something is wrong here. Oh, yes. My bad. Negative 1. There you go. And there you go. Completing the square. This is completing the square. Complete the square. Everyone happy there? 1.4. 1.4 is saying that big fraction. Yeah, also many people they got lost on this one. Uh-uh. No, this question is 100% fine when it's. Let me show you something. Let me show you guys something. Let me show you something. So, you see this question 1.3, né? Or this last one here. You see this one as it is. Now look at this. Exact same thing. It's the exact same thing. The exact same thing. And that's what I sent you guys ahead of your test. But let's begin this one. Yeah.
Sorry, sir, can you just please?
I did. I did send it before you guys wrote your test. And that was in there. Actually, all the questions, most of the questions you were asked, I sent in the group. In that question paper that I made it directly from your question paper to help you guys. So yeah, I really did think that the marks would look a bit better, but let us see test 2. We're gonna make up for it. So what we're gonna do here is for me If you struggle with this, as I've seen you guys do, let's do it like this. 3 over a minus, I don't know if I should do it like this actually, but let's do it like this, over b. Um, yeah, let's do it like this, in brackets, divided by 1 over a squared minus 1 over b squared, in brackets. Very important to put your brackets if you're missing like this. OB, okay. So why I did this is so that we can deal with each one on its own. So to get this into one fraction, I hope everyone can do this. Can everyone combine fractions like this? So division means reciprocal of this one. But yeah, let's do that as our next step. So that means a squared b squared goes on top. Oh, correct, yes, correct. Yeah, we're doing reciprocal now. Thank you very much. You're awake. You're awake. Then I factorize this here. Multiplied a squared b squared. I can, this is the difference of two squares, so b plus a, b minus a plus b, a b. Okay, now I can cancel. This AB will cancel with one set of ABs there. This AB will cancel with that AB there. This is A plus B and B plus A, so it's this one here that can cancel. B minus A and that B minus A. This 3 and that 3 will cancel. That means I'm left with a 1 and a 1 on top of each other, making my answer 1. Can everybody do this here? Can everybody do this? So, how that is working, and if we can mute there, guys, please. How that's working is if we have okay, let me do the exact same one as there. We have a 3 over a minus a 3 over b, and we want ab. We want to combine the denominators most. How I have to do that is I must take this one and multiply it with a b over b, and this one I must multiply with the a over a. Then I will be left with a 3b over ab divide by minus 3a. Then 3b over ab minus 3a over ab will give me 3b minus 3a over ab. The exact same thing will work for this one here. So I need to get a squared and b squared to combine the exponent, the denominators, right? So I must multiply this one with a b squared over b squared, and I must multiply this one with a squared over a squared. That will give me, over here, it will give me b squared over a squared b squared. Over here, I will get a squared over a squared b squared. Let's subtracting it. I'll be left with b squared minus a squared over a squared b squared. Does it make sense? Okay. Is everybody okay with the fraction now? With the fraction from the test? Can you see? Can you see? Can everybody see where they went wrong in the fraction? Will you be able to? Yeah. Tell me. So, so okay. Here I have a squared b squared, right? Here I have a ab, and there I have a ab. In this a squared and b squared, this means I have two. I have two a's and two b's. They have one a, one b, one a, and one b. So they can cancel with that there. That, that's finished. Then this b minus a, that b minus a, b plus a plus b, that's one there. There's a 3 over here and a 3 over there. They cancel. And when I cancel like this, uh, I must know that it's 1 over 1. This fraction is actually saying 1 over 1 right now, but I simplify it into just 1. Is everybody with us? Who is not with us so far? Hopefully everybody's with us. Going a bit slow, but we're gonna get there. Okay, I wonder. Uh, yeah, yeah. That's we can do that tomorrow. We can do coordinate geometry tomorrow, and also the graphs. Okay, okay. I just want to see something quickly before I do the next question. Let's brainstorm and you see. Because usually with logs, you can do things a few different ways, but then you will still get the same answer. So let us see. Can we mute there, guys, please? Can everybody try it using the rules we have? Yeah, but if you don't know the rules, then you can't do it with us. It might be right. I don't know. Maybe it's the rule I don't know. I haven't seen for M3, but let's take a look. So I have a few rules. There is a few rules. Huh. Let us use. Okay, we don't want that one. Oh, sorry. Yeah, my bad. Yeah, I was just writing it. Okay. 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 So there's a rule that say we can do like so. Log x minus 3 over log. Oh, I think I see what they did. But let's carry on. Let us see. Should be the same thing. Should get the same answer. Let's keep the space nice. So here I'm going to get if the base is 10, 10 to the power negative 1. Okay, let me do it on the side. So I have log 10 to the power 1 over 10. This will become log 10, 10 to the power negative 1. This negative 1 goes to the front, negative 1, and then I have log 10 and 10. According to my rules, what do I have? I have 1 equals to negative 1. Yeah. What I'm doing now, I'm just brainstorming. Thank you. So I have my negative 1, and then so this log 1 over 10 is now negative 1. I simplified it to negative 1. Um, so 2x minus 5. We just brainstorming it together. So, what to do now? What to do now? Yeah, it's a problem. Yeah, that's why the memo is confusing me because I don't know that rule. I don't know that rule. Log 1 over x minus 3. It doesn't make sense to me. But okay, let's do this. I don't know if we should be doing this, but let's mess and say negative 1 multiplied with log x minus 3. Then we take this over. I don't know. I don't know. Okay, yeah. Yeah, let's do that. Let's do that. Let's do that. And then x minus 3 negative 1 log 2x minus 5 equals to. So when I have logs equal to each other like this, I can take the logs away and then write it as is. And then I have x minus 3 minus 1 uh, equals to. So okay, we all know that 1 over 10 is equal to 10 to the power negative 1. Right? 1 over 10 equals to 10 to the power negative 1. They're just different ways to simplify the same answer. Ne? So I can write this here as 1 over x minus 3. Alright? We all agree there, like that. So I don't want a fraction. I don't want a fraction. So what I'm going to do is I'm going to multiply my the whole equation with x minus 3. And I'm going to get 2x minus 5 x minus 3. And I'm left with the 1 that side. What I must do now, I must expand them. So I'm going to get 2x squared minus 6x. 5, negative 5 times x is minus 5x. Negative 5 times negative 3 is positive 15. So I'm having 2x squared minus 11x. This one comes over, becomes negative. So it's going to be plus 14. Oh wow. Then what I do is I must now factorize this thing. I know for sure I'm going to have like so. Um, so 7 uh, 2x minus 7 equal to 0. 2x x equals to 7 over 2. X minus 2 equals to 0. X equals to 2. I actually see that they were correct. If you guys can see there, they got the exact same answer. See, they got this 2x squared minus 11x plus 14. They got the exact same thing. This rule, I haven't seen this rule for maths and 3, but they got the same answer as us. Got the same answer, which is that's very nice. No, this thing's not in my way. Yeah. Okay, so the reason why they cancel this two is because when you substitute this two into this log here, you get a math error. But when you put in a 7 over 2, as long as you get any number, as long as it's any number, you're okay. It's okay. Can everybody see where they went wrong? Can everybody see that it's possible to do this? Is anyone unhappy? Yes, the rules. If you don't know the rules, you might as well ignore that question. And I'll never say that. Always attempt every single question, everything. Never leave a blank space, never leave anything. Even if you make your own maths, maybe your maths is correct, then you win a prize or something, I don't know, but never leave a thing open. Okay, is everybody happy with this? Then we can go to the next one. Okay, so the next one was a very nice one. Yo, it was so sad that very little people could do this one. So this one is saying 28 times 2 to the power of x minus 12 to the power of x minus 1 equal to 0. Someone please tell me the first step. Let me pick someone. Let me pick someone. Let me pick someone. Is this Beyonce? By your niece. By your niece. By your niece, is that you? Are you there? By your niece. Ah, okay, you don't want to answer. It's okay. Who can you pick? Can you pick? Tempela. 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 Tempela, is that you? Are you there? Why is the people scared now? Yolanda, can I ask you, what do we do? You can unmute your mic, then you can tell me, please, what can we do? Wow. Wow, nice man. And then what do I do? Yes, Moose. It's 14, eh? Is it 14? Yeah, Yolanda, you don't give me the wrong answer, please. And then what do I do? Is it on 2 to the power 7? Okay. 7. Oh, I see you are running. And then wow, nice man. There you go. No, you must do that. I must do that more often. I see everyone is too quiet. Okay, exactly like this, guys. Exactly like this. Many people they didn't take this negative one over first. If you don't do this, yeah. I mean, you can do it. You can not do it. It's fine. You can factorize just these then. But don't make your life difficult. The K method. You can do the K. You can do the K method also. But usually you would use the K method if it's a long thing or like an uncomfortable uh, number. Then you would do it. But this is very simple. You factorize 2 to the power of x, then you finish. Usually. But if you can do it K method, do K method. Whatever works for you. But you will do the exact same thing. Exact same thing. You wouldn't do anything extra. Yeah. You wanna put 2 to the power of 0 over 2 to the power of 4. Oh, no, you see, you can't do that. No, you see, Is what you're saying this? Are you saying this? Are you saying this? And then we drop the bases, so it's gonna be x4 equal to 0 like that. Yeah, you see, then you will get x equal to 0. And anyways, you can't do it like this. You can't do it like this. You can't drop bases like this. Yeah. What you can do is this. If you really want to do it like that, then you must do this. You will still get to 2 -4. You can do that. If you want to do it like this, you can, but you must still divide with that 2/4, 2 to the power 4. Yeah, yeah. Always, you can only set the bases equal to each other if this is alone, if this is alone, and this is alone. When you know you've simplified it to the point where they're all alone and the bases are the same in this way, then you can set them equal to each other and drop the bases. If you haven't done it yet, I would suggest not doing it because as you can see here, if you do it too early, you will get the wrong answer. So make sure that they are standing alone. Simplified. If you have, if you have, what can we say? If you have, maybe just for example, if you had a 2 to the power of x, and I don't know, what can we say? Yeah, let's just say for argument's sake, is a 2 to the power. Yeah, it'll be the same thing on this side. If you have a, if you have a 8 over there and I don't know, plus what? How can we say 16 again? Yeah, you'll get the same answer, I guess. 2 to the power x plus 2 to the power 3 plus 2 to the power 4. You will get the same answer if you set them equal to each other. I believe you will. Will you? No, you won't, eh? No, you won't. That will be 7, and then 8 plus 16 is 20. Now you will get the wrong answers. But no, man, don't worry about this. Just your goal is in entry maths. Get this alone simplified and get this alone simplified. Then you drop the bases, the exponents. That's the best option because the steps will never change. It will never ever change. It will never change. Uh, Same base. Your goal will always be to get the bases the same and get them alone, simplify them. That will always be your goal. The steps will never change. There is a video on exponents that I have in my channel. Go and watch that. The steps, they never change. Always the same.
Always the same.
So we continue. Everybody happy? Okay. I myself haven't done this. What to do? What to do? What do we do now? Are we gonna set y equal to each other? I know that they did in the test, in the memo. What do you guys want to do? Do you want to put the one into the other one? Or do you want to set them equal to each other? So in the memo, they set it equal to each other. They set the y's equal to each other. We can do that. Or what we can do is, let's put this one into that one. And let's see what we get. Just to show different ways to do the same thing. So let's get y alone. No? So 3x minus 2y minus 6 equal to 0 equals to 2y minus 6y equals to over 2. This is number 2. And we say 1 into 2. So I have x squared minus 4 2 minus 4 equals to 0. Multiply with 2 to get this fraction away. No? So this is 2x squared. Does my 2 also multiply here?
So,
Yeah, you don't need to, no? You don't need to. You don't need to do that. Because the 4 over 2, they left with 2. Yeah, we don't need to do that. So this will be 2, 3x minus 6. Yeah, sometimes we need to work harder. You know, just work more smart. So negative 2 times 3x is 6x. Negative 2 times 6 is a positive 12 minus 4 is 0. And then 12 minus 4. 12 minus 4 is 8. The numbers now factorize this.
two and four.
2 and 4 can work, yeah? 4 and 2. And then they're both negative. I wonder if this is right. I wonder. Let's quickly check something. Okay, we can't check yet. Can we check? No. Okay, now just to get y values. To get y values, you put them into here. So we're gonna say y1 equals to 3, then y2 equals to They didn't get they didn't get these answers in our memo. There's a zero. So let's see if it's the correct answer. We're gonna say for our y1 and our x1, x1 equal to 4, yeah, this is x2 equals to 2. So we're gonna say here 3 multiplied by x1, 4 minus 2 times 3 equals to 6. That's correct. Let's do for this one. 3 times 2 minus 2 times 0 times 0. Correct. Let's put it in that one. 4 squared minus 4 times 3 equals to 4. That's correct. Let's try the other one. 2 squared minus 4 times 0. Correct. Okay. Let's try the ones that didn't. Does everybody understand what I'm doing? I'm checking if our answer is working. And they are working. We're getting the values we're supposed to be getting when we check. Um, it's just the test they didn't get this. They got y equal to 0. Can everybody open the memo? Can everybody see what I'm seeing? They got y equal to 0, and then they got x equal to 2. They got that two values, but not negative 8 and 15.
Yeah, because here we got the
All our answers is working out. Yeah, you must solve x and y simultaneous. Here is a linear equation, yes. This is our line graph. This is our parabola. Yeah, yeah. I don't know why they would go that route to set them equal to each other like that. That is, I mean, as long as it makes sense mathematically, it should be fine. But let's test their answers. If they got x equal to 2 and y equal to 0, that means they got this pair over here. That means that x equal to negative 8 and that y equal to 15 should be together. So we're going to try that now. So the x is negative 8. So 3 times negative 8 minus 2 times 15. You see, it doesn't work. This is crazy. Doesn't work. And if we do the other side, negative 8 times negative 8 squared minus 4 times 15. 124. See, that's way off. So that one set is wrong. That one set is wrong. I will bring this up with the tutors and see what they say. But these answers are all correct. These are all correct because we tested them and we got the values we're supposed to be getting. We got that. I don't include this number, but I get 6 and I get 4. I hope I'm making sense. But our answers is working out 100%. In the memo, only one step.
That makes more sense, yes.
Yeah. I don't know. I'll have to discuss with them. I'll see what they are saying. Perhaps they have a reason for their answer. But yeah, man, I don't know. 3x? Yeah. Yeah, 100%. Yeah. Yes. Level. No. No, you can start any single way, any way. You can even get the x's equal to each other and solve it like that. You can get this y alone and put it into that one. You can do that also. You can do it many ways. As long as you get the same answer through manipulation. I just want to check something. So this is 12. This is 12. 12. Oh, I think this. Let me, let me see something. They got x squared minus 4 x squared minus, let's start here, 2 6 minus 3x equal to x squared minus 4. So this is 12 minus 6x equal to x squared minus 4. Then I got everything one side. So this side minus 12 minus 6x. And I got this. Yeah. Oh, this is positive. I got this. Minus 4 is 16. Yeah. Yeah, no, I'll ask them. Let me take a picture of this now actually. Before we forget. Just a question, just to ask them, you know, if some people got 3 and 4, like we getting, can they get the mark? Because it still works. But like, then again, it is a graph. Who knows? Yeah? Let us see. Okay, the last question I'm gonna do is subject of the formula. You know, I was a bit sad that no one could get this one because let me see, not no one, but like maybe 2 out of 21, like that. I mean, like that, like 2 out of 20, 5 out of 20 people, they could do that, which was a real problem, man. Yay. Oh, there's someone trying to join us. Shame, man. Yeah, welcome back. Welcome back. Um, yeah. Okay. Okay. Good. Solving for x. First thing we do, we see. Okay. Um, my my the thing that is in the thing attached to my exponent that I want is alone. There isn't anything here. There isn't any letter, any variable, any number. If there was, I would have to divide by this thing to get it there. To get to get this alone, to get this standing alone by itself, not with anything attached to it. If there was something attached to it, I would have to divide by this thing, whatever it may be. There's a question that I gave you guys over here. There's something attached to the thing I want in the exponent. I want d there. There's something attached to that thing there, ne? To that variable there. So I must divide with this n first before I can log both sides. Just to let you know that we do get something there and what to do when we have something there. Someone is joining us again. So first thing we can do now is, because we have a loan, it's a loan there and nice to work with. I must now log both sides or learn both sides. You can log or learn. Usually they learn as letters, but let's use log today. So I'm gonna log this, log a minus. Yeah, usually they would want to use learn when it's letters and then log when it's numbers. But you can use either or. They're the exact same thing. It's the exact same thing. So I've now logged both sides. I'm logging because log is the only thing that I can use. Log has the only rules that I can use to bring an exponent down into a number. And you should know your rules by now, or we're going to know them by the end of this weekend. I hope that I can take my exponent down like this. So I want x. To get x alone, yo, Nina is keep on jumping in and out. To get my x alone, what I have to do is divide with anything that is not my x. And then I'm finished. You divide with anything that's not your x. Does it make sense? Very, very simple. Lovely. I don't want to do the last question because it's a word sum and we must think. A- And anyways, this question, it is in the word sums videos that I sent you guys. It is in there. So those who watch that thing, they got these marks. But let's do it because it's the last question of the day. Let's just do it. So, okay, let me rewrite it. A mother. Now we analyze the question. So that's the important thing. So there should be an age for the mother and an age for the daughter. This is the current ages, ne? The current ages. It's the current age. Then the speaking. She will be twice as old as the mother. Okay. Then the speaking of 12 years. So we must have for 12 years from now, from that time, in 12 years. Mother and then daughter. Someone is joining us again. Yo, how are you joining in the end of the video? Okay, so So they say a mother is 3 times as old as her daughter. 3 times. 3 times means what? Means 3 multiplied by something. So we are calculating the age. So we need a variable that is going to give us this answer. We can't just say 3 what? 3 times what? So we're going to choose a variable. So whenever you do word sums, you always choose the variables and the equations you're going to work with, right? So you can choose anything you want. So a mother is 3 times as old as a daughter. So let's say the daughter is 6 years old, uh, and the mother is three times the age of their daughter. It is 6 times 3. All right, but we don't know the age of the daughter, so that age will be x. So the mother is means equal. Is means equal. 3 times means multiply. Multiply. This is that multiply there. So a mother is 3 times the age of the daughter. So the daughter is the x. The age of the daughter is the x, and the mother is 3 times that value. So the mother is 3 times that value, and the daughter is that value. Okay, then they say, yeah, do I have a different color? Yeah, it's not the best color, but okay. In 12 years, she will be twice as old as the daughter. How old is the mother? Twice as old. I'm not sure about that 2x. Or that 2. I think that 2x will come afterwards. But okay, let us leave that. Let's leave that. So in 12 years, that means it's in the future, right? In 12 years. So in 12 years means the future, means ahead of time. That means 12 years plus their ages. So it is saying 3x plus 12 in 12 years, right? And then x plus 12. But we have to keep in mind that they are saying she will be twice as old as the mother. She'll be twice as old as the mother, as the daughter. In 12 years' time, she will be twice as old as her daughter. In 12 years, she will be twice as old as her daughter. Does it make sense? In 12 years, she will be twice as old as her daughter. So the daughter is times 2. Right? Something must be multiplied by 2. Yes. Yes, yes. It is 12. So here they said in 12 years, she will be twice as old as her daughter. In 12 years means in the future, ahead of time, according to my story that I have. So they are saying ages, the current ages, but then they say also in 12 years, meaning in the future. So that's why I added the 12 year to the current ages. Then then I multiplied the two because it's saying twice as old. Then I multiply in 2x. 2 times 12 is 24, not 12. Then I solve x as normal. Then I get my x value. My x value, according to my formulas that I made here, is the daughter's age. Then the mother is 3 times as old as the daughter. So the daughter's age multiplied by 3. Yes. Yeah, I hope everyone can see the mistakes that they made, or at least the eyes open now to how they should have dealt with the paper. Yeah, there was a few places where you could have scored marks for real actually. For me that was 1.2, this one there, this one over here, this one there, this one there, and even this one here actually. For me that should have been your marks. The only challenge is that 1.1 and then 2.1.1 and the last question, but I gave you that also, so that shouldn't have been a problem. The only issue should have been the log and that 1.1. That should have been your only problem. Any questions? Is anyone not with us? Does someone want me to repeat something? If you don't say anything, it means you are at peace, you are understanding, you are with us. Yeah. Hmm. Yeah. I must still mark the papers that I got the other day. Because yeah, I've been very busy. I've been very very busy. I had actually a private lesson with a student this afternoon. So I think I finished what time? I finished like around 3:30. That's why I couldn't be on time for our lesson. But we got to it. We got to it. But don't worry. Tomorrow we tackle the coordinate geometry and then we tackle the algebraic cross. And then from next week on, if we're all happy, then we do trigonometry all the way.